Right, good afternoon and welcome to Master Talker online class. If today is your first time watching our video, please consider subscribing. We want to solve this question. They said a binary operation this, okay, is defined on a set of real numbers this. I told you that they will give you the formula. They say where this and this belong to R. Don't forget that R means the set of real numbers. Okay, if you don't understand what they mean by set of real numbers, please go back to my video on number system for you to understand what real numbers are. Okay, the first one, they said that we should determine whether or not the operation this is commutative. And don't forget what I told you about commutativity. Commutativity is simply that if A operates on B, that you will get exactly the same result as B operating on A. Okay, so let us check that. They have given us already that A operates on B is equal to what? Is equal to, okay, they use X and Y, so let us use X and Y. So they've given us X operates on Y. We want to check if it is equal to Y operating on X. So but they have given us this one to be what? X plus Y minus 2XY. Is it the same thing as saying anywhere you see X now, anywhere you see the first one, change it now. This one will now be Y plus what? X minus what? 2YX. Now, are they the same thing? Let us check out. This is X plus Y minus 2XY. The same as X plus Y is same as Y plus X is same as X plus Y. They are the same thing. And YX is same as XY minus 2XY. So, since they are the same thing, we will conclude that what? That this operation is what? Is commutative under we conclude that it is what? Commutative. Okay, as simple as that, we conclude that it is a commutative. So the operation this is what? Commutative. So number two said find the identity element of R under this operation. And I told you for an identity element that if something operates on its identity element, that you are getting yourself back. Okay, you are getting yourself back. So so the identity element of this. Okay, so let us get the identity element. In getting the identity element, we will say that identity element simply means A operates on E must be the same thing as, okay, this is the operation, sorry. It's same thing as what? E itself operating on A, and you get your A back. Okay, so let us check that. Let us now put it here. If we put it here, we are operating on what? We are putting it here. Let us put it here. So we are having A operating on E is equal to what? A plus E, okay, minus what? 2AE. They say is equal to, you must get back that A. Okay, you must get back that A. So let us do the magic here. If we do the magic here, let's collect items to get what our E is. We need to get what our E is. Can this one come here? Yes, I'll have what? E minus 2AE is equal to what? A minus A. Okay, and A minus A is 0, but they have E in common. So this minus this, I'm going to have 1 minus what? 2 what? 1 minus 2 1 minus 2A, okay, is equal to this minus this 0. So what do we have now? That E is simply what? 0 divided by 1 minus 2A, which is what? 0. Okay, so the identity element here is 0. We have gotten the identity element. The identity element is what? Is simply 0. So the next one, that's number C. Number C said find the inverse of a general element P where P belongs to R. Okay, we know that P operates on its inverse. Okay, I'm going to get an identity element E. I'm going to get an identity element. And we have gotten that the identity element of this thing is 0. So what do we mean? What do we mean? That when P operates on this, so I'm having P operating on 1 over P is simply to substitute in this formula. So I'm having what? P plus 1 over P minus 2P times 1 over P, okay, is equal to what? 0. As simple as that. Okay, so what do we have now? We are having that, remember that what we are looking for is 1 over P, and you cannot say that this will cancel this. Okay, they don't cancel like that. Just know that this is a different operation on itself. So we are looking for the 1 over P. So if we factorize, we are going to have that, in fact, let's take this man to this side. So I'm going to have, I want to solve here to get my 1 over P. So I'm getting that what? P. In fact, me using 1 over P will make you confused. Okay, I don't want to use 1 over P so that you're not confused. Let me use Q. Then P operates on Q, okay, that I'm going to get an identity element. That is what, then we'll now conclude that this Q is what? Is the inverse of P. So let us do that now. So if P operates on Q, the answer I'm going to get is okay. So let us do that. If P operates on Q, anyway I see X, I'll put P. Anyway I see Y, I'll put Q. So I'm having what? P plus what? Q minus 2PQ is equal to what? The identity element. And we have gotten that the identity element is 0. So it should be equal to what? 0. So now let us find our Q. So we now have that what? Q minus 2PQ is equal to, this one can go here to have what? P. Okay, so if I factorize, I'm going to have Q is common here. I'm having 1 minus 2P, okay, is equal to what? P. So if I leave Q to stand alone, I'm going to have P over 1 minus 2P. So this is the inverse of the P. This is what? The inverse. This is the inverse of P. This is the inverse of P. We have gotten it to be the inverse of P. Okay, so the next thing they say we should find is they said find the element of R under the operation this that has no inverse. Okay, the one that has no inverse. For it to have no inverse, it means that the denominator will be 0, that the inverse is undefined. Okay, for it not to have an inverse, it means that the inverse is undefined. So for it not to have an inverse, we have that Q must be equal to undefined. Okay, and we have gotten Q to be what? P over 1 minus 2P is equal to what? Undefined. And what will make something undefined is when the denominator is 0. So we have what? 1 minus 2P is 0. So let me solve it here. 1 minus 2P is 0. So therefore 1 is equal to 2P. So therefore P is equal to what? 1 over 2. So if you put 1 over 2, if you put 1 over 2 here, it will make the inverse to be what? Undefined. So it will not have an inverse. So that is that. Then lastly, let us solve the last one. The last one is option E. He said we are now operating with 5 root 2, okay, operating on 10 plus 7 root 2, okay. So it means anywhere I see X, I'll put the first one. Anywhere I see Y, I'll put the second one. So this thing is equal to X here, which is what? 7 minus 5 root 2, okay, plus 10 plus 7 root 2, okay, minus 2 into 7 minus 5 root 2 times 10 plus 7 root 2. So you have to clear the bracket. So I'm having here 7 minus 5 root 2 plus 10 plus 7 root 2 minus in fact 2 times this will give you 14. This time this will give you 10 root 2 times 10 plus 7 root 2. So let us clear the bracket. I'm having this plus this will give you 17. This and this will give you plus 2 root 2. Okay, minus 5 root 2 plus 7 root 2 will give you plus 2 root 2. So I'm having minus in bracket of, now let us clear. 14 times this will give you 140. 14 times 7. 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 I'm having 98. So 14 times 7 will give you 98 root 2. Okay, this time this will give you minus 100 root 2. Now minus 10 times this will give you minus 70. Root 2 times 2 will give you 2. Root 2 times root 2 will give you 2. So I'm left with what? 17 plus 2 root 2. This time this will give you minus 140. These 2 will give you minus 2, right? Minus 2. Minus 2 plus times this will give you plus 2. Plus 2 root 2. So this one minus times minus again will give you plus 140. Because this time this is 140. Okay? So what do we have now? 140 minus 140 gone. Root 2 plus root 2. I'm having 17 plus what? 4 root 2. And that is the answer. 17 plus 4 root 2. As simple as that. So let us solve another question so that we can understand better. Another one said that a binary operation star is defined on the set of R of real number by A star B is equal to A squared plus B squared minus AB. A squared plus B squared minus AB. Okay, for all, this is for all in mathematics, for all A and B being an element of the real number. Okay, A, show that star is commutative. Show that star is commutative. Okay. B, let's equally show that star is closed. Okay. C, show that let's say show whether or not, let's put it like that, show whether or not star is closed. Show that star is not associative. So that star is not associative. Then D, show that 4 star x is equal to 28. Show that, okay, solve the equation, not show that. Solve the equation. Solve the equation this. Then E now said calculate I 2 star minus 4 I 2 in bracket of 2 star in bracket of minus 4 star 1. Okay, I 2 star in bracket of minus 4 in bracket of star 1. Okay, so that is that. Okay, so it's a very simple something, so let us do that. Solution. The first one said that we should show that that star is commutative. What did I tell you about commutativity? Commutative is that A operating on B must give you the same thing as B operating on A. So we know that A operating on B is A squared plus B squared minus what? AB. Okay, then B operating on A means B squared plus A squared minus BA. So bring this one down. A squared plus B squared minus AB. Is this in the same as saying A squared plus B squared minus AB? Yes. So therefore star is commutative. Okay, that is for A. Done. B. The next one is show whether or not star is closed. Now closure said that A star B, okay, must which is equal to C, and that C for all A, B and C being an element of that same real number where that star is coming from. Like if you operate these two, any answer you get must be found in that same real number. So since we have that A plus B is equal to A squared plus B squared minus AB. Now, is this answer going to come from a real number? Yes, it's going to come from a real number. Any answer you get here must be a real number. If you put any two real number here and work on it, it must give you a real number. It can never give you a complex number. So it is closed. We now say that what? Star is closed under what? Real number. Okay? Then C. Or we just say that star is closed. Now this one said that what? Show that it said show that star is not associative. Now associativity is when we have that A operates on B, okay? A operates on B, then operates on C. Is it the same thing as saying A operates on B, then the answer now operates on C? Okay? Now, if they have concluded that it is not it, what you have to do is just find anyone that will not work. Find anyone that will not work. In fact, from this thing they gave me, let me try if this one will work. Let me try if this one will work. Okay? I can clean here now. Let me try if this one will work. Let me try 2 star in bracket of minus 4 star 1. We want to check if this thing is the same thing as saying 2 star minus 4 first, then star 1. Then if the both of them gives me the same answer, then we know that we cannot conclude yet, but let's see if both of them will give me the same answer. Or in fact, let me use the general term. But once you can use any one that will not work, we conclude that everything has scattered. So let us just find the answer to this, since we are asked to find the answer. Okay? But if not, you can solve it generally. If they did not ask you to do that, you can solve it generally. But so let us solve this one first. This one said 2 star minus 4 star 1 is equal to, let us check it. First of all, let us get this one. 2 star. Getting this one, let's know what this one will give us. This one will give us, these two people will give us minus 4 all squared plus 1 squared. Then minus 2 into minus into minus 4 into 1. So this is 2 star. Now, if you do here, you are getting 16 plus 1, 17. 17 plus 4. Because here is giving me 4, that is 21. 17 plus 4 is 21. So I'm having 21. So everything here, let us now working on 21, which is the same as saying using the same formula. That is 2 squared plus 21 squared minus 2 into 21. So which will give you what? 2 squared is 4 plus 21 squared is 441. 441 minus 2 times this will give you 42. So if you do everything, you are getting 403. Okay, I have gotten my II. Note that I've gotten my II. So let us check if it's the same thing as saying. Let us check if it's the same thing as saying. If it's the same thing as saying 2 operating on minus 4 first before you now operate it with 1. Let us check if it's the same thing. Now 2 operating on minus 4 means 2 squared plus minus 4 squared, then minus 2 into minus 4. Okay, then don't forget this answer will be operated on 1. So I'm having 4 plus 16. 4 plus 16, then plus 8 is going to operate on 1. So this plus this is 28. So I'm having 28 is operating on 1. 28 is operating on 1. But in this one is 2 is operating on 21. So they are not even the same thing. But let us just conclude. Let's not conclude. Let's get this operating on this will give me 28 squared plus 1 squared, then minus 28 into 1. So which will give you what? 28 squared. That is 28 times 28. You're having 784 plus 1 minus 28. So I'm having 725. So 757. So you see, they are not equal. It's not the same thing as when we got 403. So we conclude that what? We conclude that what? That star is not associative. Star is not associative. So that is that. It's not associative. Okay? So what else do we talk about? So the next one, they say an assignment, do this one and do this one and tell me what the result will give you on the comment section. Okay, so find that too and tell me what the result is on the comment section. So let us solve another question. Now let us solve another question. This one said let R denote the set of real number let R denote the set of real number, a binary operation star is defined on the set R minus 1, okay, by x star y, which is equal to x plus y plus xy. Okay, they have given us the formula for all x and y being an element of the real number. Okay, then A said we should show that whether or not I star is commutative. Show whether or not Y is commutative, II star is associative. Then B, determine the identity element. Determine the identity element. Determine the identity element. Okay, very, very simple. So what do we do now? Okay, now they say that, listen, they say that that star operates on real number minus -1. So inside real number, you are going to remove -1 inside it. So the rest of the real number. So we want to show that it is commutative. And you know that commutativity said they gave me the formula that s plus y is equal to s plus y, sorry, s star y is equal to s plus y plus xy. Okay? So if you look at that now, commutativity said that a star b must give you b star a. So let us put it. A star b is what? A plus b plus ab. Is it the same thing as saying b plus a plus ba? Yes, they are the same thing. A plus b plus ab is the same thing as this, and this can come first. A plus b plus ab. Yes, so therefore star is commutative. Okay, commutativity holds. So star is commutative. Okay, so it is commutative. So the next one is associative. Is it associative? And associativity, I told you what to do in associativity. Associativity means that if A operates on B, okay, then use the answer to operate on C. Is it the same thing as saying A operates on B, operates on C, like this? First of all, say B operates on C before A will now operate on them, okay? So let us get that and know if it is true. Let's get that and know if it is true. First of all, let's get A star B star C, like this. Is it not saying, first of all, A star B is giving me A plus B plus AB, okay? That is A star B. Then I want to use this thing to operate on C. So which means anywhere I see A in this formula, I'll put all these things. Anywhere I see B, I will now put this one. That's the meaning, because this thing is what is operating on this. So I'm seeing A here, so I'm putting everything here. A plus B plus AB. Then I'm seeing this, I'll put it as what? C plus this one again. A into, sorry, what is my A? This is my A. My A is what? A plus B plus AB into C. Okay, so this is the answer I got. Then if I clear the bracket, I'm going to have that it is what? A plus B plus C, then plus AB. Okay, this time this will now give you plus AC plus BC, then plus ABC. So this is the answer I got when I did the first one. So let me do the second one and know the answer I'm going to get. Let me do the other one and then know the answer I'm going to get. So what we want to check now, we have checked A star B before star C. So we want to check now A star B star C. Okay, that is so for us to check that, we will have, let us do the one in brackets first. That is A star. Now doing the one in bracket, anywhere I see X, I'm putting B. Anywhere I see Y, I'm putting C, which is what? B plus C plus BC. Then I want to use this now to operate this, which means anywhere I see X, I'm putting A, but anywhere I see Y, I'm putting all these things. So let me put that. A plus, let me put everything. B plus C plus BC. Okay, then plus, what did I just do now? Plus, now anywhere I see X, I'm putting A, then anywhere I see the other one, I'm putting B plus C plus BC. So let's see what the answer will give us. A plus B plus C plus BC plus this time this AB plus what? AC plus ABC. Are they the same thing? Are they the same thing? Okay, this is A, B, B, C, C, AB, AB, AC, AC, BC, BC, ABC, ABC. So since they are equal, we say that what? Star is what? Is associative. Associative. So since they gave us the same thing, it is what? Associative. So the next thing we need to look at is what? We should find the identity element. Let us determine the identity element. there's a place they say we should solve an equation. Okay, please, I'm going to solve that, please. In the other question, they say we should solve an equation, so I'm going to solve that. But let's just continue. The next one say we should get the identity element, and I told you that what, that if A operates on its identity element, that you are still going to get that A back. So let A operate on identity element. So anywhere I see X, I'm putting A. Anywhere I see Y, I'm putting identity element. So I'm having what? A plus E plus what? AE is equal to what? A itself. So let me collect items. I'm having that E plus AE is equal to what? A minus A. So therefore, E plus AE is equal to 0. So I'm having a what? E in bracket of 1 minus A is equal to 0. So therefore, E is now what? 0 over 1 minus A, which is 0. So the identity element here is what? 0. The identity element here is 0. So let us solve the other question. The other question, they gave us the operation. That one, they say we should solve the equation. They gave us an operation A star B. They say it's equal to what? A squared plus B squared minus AB. Okay? Then I say we should solve the equation 4 star X is equal to what? 28. So let us solve it. First of all, let's get 4 star X, which means anywhere I see A, I'll put 4. Anywhere I see B, I'll put X. So I'm having what? 4 squared plus what? X squared minus 4 bracket X is equal to what? 24. So what do we have now? I'm having X squared minus 4X, this one, plus 16. This one coming here, minus 24 is equal to 0. So I'm having X squared minus 4X, 16 minus 24. You have 24 minus 16. So I'm having 8. So minus 8 is equal to 0. So this is a quadratic equation, and let us factorize. If we are factorizing, I'm going to have x squared minus, let me check, 8, 2 divide 4, 2 divide 2, 2 divide 1. So I'm having, is it factorizable? How did I get 28? Okay, 28, not 24. Sorry, 28. 28. So this is 12. Okay, so 12, 2 divide 6, 2 divide, so which is 6 and 2. So I'm having minus 6x plus 2x minus 12 is equal to 0. If you don't understand this, please go and watch my video on factorization of quadratic equation. You understand that. So I'm having x into x minus 6, then plus 2 is equal to 0. Therefore, x minus 6 and x plus 2 is equal to 0. So therefore, x minus 6 is 0, or x plus 2 is 0. So therefore, x is equal to what? 6, or x is equal to minus 2. So that is that. Okay, it's very, very simple. So let me check my time. Okay, so let me give you an assignment that you will look at. Okay, take down the assignment. The assignment here said, okay, they said a binary operation is defined on set of real numbers, okay, by x star y, which is equal to xy over 4 plus x plus y for all x and y be an element of the real number. Then I say A, find the identity element. Okay, find the identity element. Then B, the inverse. Then C, show whether or not star is I commutative. associative. Okay, then D, solve the equation x star 6 is equal to 36. Okay, so do that and share the answer at the comment section. Thank you very much for watching. Please consider subscribing.